Hey folks, it's Tom, your FrugalPrepper. So, I always want to say at the outset of this video, I'm not an electrician. I'm not an electrical inspector. This is just according to the current National Electric Code, as best as I could tell for my situation. My breaker box is internal, my main disconnect's internal. I don't have an external disconnect. I don't have an external breaker box. These things differentiate how you hook this up. But I had a lot of people, when I was doing my last generator testing video, say things like, that's dangerous, you're backfeeding the electric system and you're going to kill linemen, or you should hook a ground rod to the generator and run a extension cord out and hook it up to the ground rod. So there are generators that have bonded grounds and generators that have isolated grounds, non-bonded grounds and neutrals, and you need to know which one you have for which situation. So I'm going to cover my setup and how I did it, and this meets National Electric Code as best as I can tell from reading through the 2023 edition. But you know, I would suggest, if you don't know about electricity, you probably want to call somebody for this. My panel mains comes in here, right? Inside this panel, the ground and the neutral are bonded. I have a 10 gauge wire with a separate ground and neutral on it coming from my plug for my generator. It plugs in, it runs to this 30 ampere. This has an interlock on it. So in order to turn on the generator backfeed breaker, you have to turn off the main breaker. Now, I do not have a separate transfer switch, right? A lot of transfer switches you get do not switch to neutral. Some of them do. When you switch the neutral, you need your ground to be bonded on your generator. But in most cases, we're not switching the neutral. So ground and bond are together here. When I plug in that plug from the generator, my ground and my neutral are bonded here, right? Because that's always hooked up from the plug into here. The only things that feed off this breaker are the two hot legs coming off the generator. They're 120 volts each, and between both of them they're 240, and they have a neutral. That neutral needs to be bonded to ground. It's bonded in the panel. I have unbonded the neutral from the ground in my generator. This is just generally speaking, you need to check it, and I'll show you how to in a minute. Most of your pure sine wave inverter type generators do have an isolated neutral and ground. And most of the older style generators, they're bonded. That's not always the case though, right? Some cheap Chinese generators will say they're bonded in the manual, but you check them and they're actually isolated, right? So you need to check this on your particular generator. But if you don't have a transfer switch that switches the neutral, you need to unbond your ground and your neutral in your generator. Otherwise, you're creating a separate path. You could have a failure in here and still have current flowing through that neutral and ground out in the generator. So that wire that hooks up the neutral and ground is only like a 14 or a 16 gauge at best. It's not going to handle 30 amps of current. If you have a failure in here, you're going to end up with a fire, right? So you don't want them bonded. Normally, when you're just plugged directly into the generator, you do want them bonded. And if you have a neutral failure, your appliance is going to quit working because it has no connection to neutral. When you have two panels, or a generator in a panel, both with bonded, you could have a failure in here and it could still get a circuit through that, and that could start a fire. That could also get you shocked if you touch if there's current going through that ground path to the generator and you touch it, you get shocked, right? So you want those isolated. You do not want to run a separate ground rod, because you're creating two paths to the ground from two different places. You can run multiple ground rods or whatever off of your main panel. I think they have to be 6 feet apart, but you can run as many of them as you want. The local electrical inspector here says only one off a main panel. But National Electric Code, I believe you can put as many as you want as long as you're 6 feet apart. But you can't run one to a generator and one to a house when they're both drawing or using power. You have two separate paths to ground. A failure that goes to ground will then not trip a breaker necessarily in here because it's found an alternate path. They have to come back to here to blow the breaker. But basically, you know, this is the back feed coming in. As far as hooking up a separate ground to go out to the generator or separate one to a ground rod, but run an extension cord outside and hook it up. Somebody said something like this because of the resistance in your wires or something. No, your ground and your neutral come in this wire. They hook up to the bonded terminal up here, right? So they're bonded through this wire. There's no reason to run another one out there. I think some people just get crazy and think grounds are safe. We hook up more grounds, ground, everything. No, you're not supposed to do that. As far as people who said, oh, your generator doesn't look like it's big enough to power a whole house. My generator can put out, I think, 7,500 watts continuous and 9,000 watts peak. That's more than enough. I have a gas stove. I have a gas hot water heater. The only thing that I have to leave off is my dryer. And I wait 5 minutes to turn the AC back on because the compressor needs a little time before it'll re-engage. My air conditioning draws about 12 amps on the initial start, and then it drops down to 8 to 9 amps. Right. I have 30 amps of available power. That's probably the biggest user of electricity is the air conditioner. The microwave draws quite a bit. It's a big microwave, 1500 watt, but it seems to run just fine. So you have to kind of think about everything you're powering, sure, but this is big enough to run my whole house. And I can run the dryer, but I have to turn off the central air and turn off some other lights and stuff like that, and then I probably have enough to run the dryer. But we have a clothesline, so for an extended power outage, we're going to go out and hang our clothes up on the clothesline and let them dry out there. So now I'll take you out and show you how you isolate the ground to neutral on your generator. Alright, so this is my L630P extension cord. I have several of them, or 3 of them, just so I can run all the way up to the front of my house from the garage. I know, oh, carbon monoxide, you're not supposed to run them. This is not normally an inhabited garage. I set it so the exhaust is pointing out right up to the door, and I run a couple of big fans. I open my side door. It blows around. Most of the exhaust goes outside. This generator does have a carbon monoxide detector built into it. It will shut down if there is carbon monoxide. But don't rely on that. Make sure you keep it vented. But I'll take my extension cord. It goes into this L630P right here, right? And that will get stretched out clear down to here where it goes into my house. Now, if it's not raining, I can just wheel it out here and hook it up. But if it's raining, I'll just run the cord. And that comes to here. Here's my main electric service coming in. Here's my generator outlet. Oh, it plugs in right there. And then from this, the ground and neutral are bonded inside, right? So you don't need to bond them on the generator. All right, let me show you how you isolate this ground and neutral next. All right, so right now I've unbonded this ground and neutral in this generator. I've kind of taken it apart. I took the tape off of the wire to show that to you. I have my special plug here. I'm going to plug this in right now. I'm going to go into what this is later, but I'm going to plug my special plug in, right? And now I'm going to measure between my neutral and here. And I have my multimeter set on continuity. You can hear it beeping, right? I take this plug out and I measure between there and neutral, and I get nothing, right? So the way this works, let me show you here. I'll pop this off. You first. So in mine, the connection for the neutrals right here, I normally have it taped up. I untaped it just to show you, but it goes down on this, and it bonds to this ground wire right here, and that grounds your neutral and your ground wire. So you want to unground that, and then I of course put some electric tape around it, and so now there's no bonding between the ground and the neutral. So let me measure between this white wire and that side of the outlet. So if I go like here and I go to here, I have continuity there. So that's the neutral side of the outlet. And so what I do is, when I'm running to the house, I leave it unbonded, right? Because I'm bonded in that electric panel, and I don't want current to come out here and flow between the neutral and the ground to the bond. So you don't want current regularly flowing through that bond. But when if I'm going to use power tools or something else with this, I'm going to plug in extension cords. Then I have this I can plug in, which re-bonds that so that these GFCIs and breakers will work okay on here. And that's the safe way to do this. You could like put a little switch in or something too, however you want to do it, but that keeps it unbonded normally. And then I just leave this in case I need to use it as a portable generator. I have a much smaller generator that I normally drag out if I need to use it to power something, and this one's only for powering my house. But I guess, you know, there could be a day when I would need to use it, so I just leave this hang on the generator, and I'll use it if I need to. But that's how you can do it. That's how you unbond your ground from your generator. That's the safe way to do it. You don't. Okay, so real quick, your ground is this pin and your neutral is this one. So facing down is the one on the left. Right here is a plug. That arrow is pointing to the neutral side, right? So when you plug this in there, you want the neutral to be connected to the ground. It's real important, if you've isolated the ground on the generator, right, from the neutral, and now you put this on the wrong side and you plug it in, you've just electrified the chassis of the generator. So you don't want to do that. You want to make sure that's in the right place. And you can always just hook a switch up or something to that too, if you want to have a quick switch to connect the white wire to ground, unconnect the white wire from ground. But that's how you normally want to make this plug, and then that will bond the ground and the neutral for when you're running local, and you can unplug this and unbond it for when you're powering your house. Alright folks, I hope that all makes sense, but basically you want to have that ground and neutral isolated on the generator. You don't want to run a separate ground rod, because that will create a second path to ground, and that can be dangerous and cause problems. So you if you hook it up and you have a bonded generator and you're hooking it to your house, it's not the end of the world unless you have a failure. And then it can be the end of your world. So, I would definitely look and see if my ground and neutral are bonded and unbond them when I plug them into my house. You can use a little switch or something to do that little connection for grounded and ungrounded. I've seen people do that. I just use the plug. But that is the correct way to power your house. All right. I'll talk to you all later. This is Tom, your Frugal Prepper.